Hello guys, so this is the weekly review, part 2. So let us look into this question together. So ln of x minus ln of 1 over x. Now you see that when we have negative, this is basically equal to positive ln of x. So in fact what we end up getting is this. Ln of x plus ln of x equals 2. Now that means we end up having ln of x must be equal to 1. Then what is the value of x? X has to be equal to e. Alright, let's look into this one. Now when we want to take the derivative of this one, we have, as you can see, we have y, which is the variable, x, which is the variable, and ln of x is also derivative. So what if we simply said y equal to x to the ln of x? And ultimately what we're looking for here is dy over dx. Now then, when you take the ln on both sides, then what we end up getting is ln of y is equal to ln of x to the ln of x power. Well, by the power, we can bring this ln to the front. Now, that means this simply becomes ln of x entire thing squared. So as we take the derivative, then we get 1 over y times y prime, which is equal to 2 comes out, and then ln of x. By the chain rule, we will end up having 1 over x. So therefore, y prime, which we are looking for, is simply y times. So 2y times ln of x over x. What is equivalent to this one? It seems to be that choice C is our answer. Alright, number 28. Number 28, as we have talked about it in class, we have to realize that when x equals 3, the graph will, like the V shape, change its slope. So what's going to be happening here is, imagine if this is x-axis and that's the y-axis. The graph that we are looking at here will come down like this and goes up. Now where this value here is equal to 3. That means 4 could have been around here. 2, 1. So we're looking for area 1 through 4, right over here, under this curve. Now, in this case, what's going to be happening is this base is 2 and the height is 2, so therefore area of this one is simply equal to 2. And here, 1 times 1 divided by 2. Area becomes 1/2, so when you combine them, what we end up getting is 5 over 2. Now, but for this question, you will not see this question on the next exam, but the following one. Alright, so here we have what is the inverse function. All we have to do is, let us say y equals x over x plus 1. Then what we can do is, getting the inverse would have been x equals y over y plus 1. Then what we can do is, by cross multiplying, we get y equals xy plus x. Since we want to solve for y, then in this case, we have y minus x times y equals x, where then y becomes x over 1 minus x. That becomes the inverse function, which is right over here, choice C. Alright, absolute maximum. As soon as you reach the word absolute maximum, then we have to check up on the endpoints, along with other critical points. So here, when we look into f prime, then we end up getting 3x squared minus 6x. That's what we end up getting. So if you set this one equal to 0, we get to realize that 3x is common, so we have x minus 2 is left, equal to 0. That means x can be equal to 0 or 2. and both of them happen to be the part of this uh, interval. So when we have x and we have y, and -4 because it's an endpoint, 0, 2, and 4. We have to check up on all these 4 points to see which one of them will be absolute maximum. Now, of course, when you plug in -2, let's try looking at that. It becomes -8, and then -12, and +12. So it becomes -8. When you plug in 0, it simply becomes 12. So obviously this one is not in. When you plug in 2, it becomes 8, and then this portion becomes -12. So it becomes negative, in this case it simply becomes +8. Now when you plug in 4, we end up getting 64 here, and minus 4 squared becomes 16, so we end up getting 48 plus 12. Now, here what we end up getting is then this becomes 16, and then so in fact we end up getting 28. So absolute maximum in fact occurs when x equals 4. So therefore our answer will be choice number A. Alright, so here we have, in fact in this case we have to use the sum of the angles for the cosine ratio. So here we have 4 times cosine of x times cosine of pi over 3 minus sine of x times sine of pi over 3. Now, here we get to realize that this is equal to 1/2, and this is equal to radical 3 over 2. By multiplying by 4 on both sides, we end up getting 2 cosine of x minus 2 radical 3 sine of x. So we're looking for something that looks like this, which is choice B becomes our answer. Alright, here we have dz dt is equal to 1, and then dx dt is 3 times of dy dt. Now, what is the value of dx dt? It seems like all 3 sides are changing here. Then, the relationship which you can have is x squared plus y squared equals to z squared. Then we have 2x dx dt plus 2y dy dt, which is equal to 2z dz dt. Here we end up having 2 can cancels out. And then since what we are looking for is dx over dy, dx over dt, here you can technically solve for dy dt is equal to 1/3 dx dt. Now, when we're plugging everything, when x equals 4, dx dt plus y being equal to 3, and dy dt is equal to 1/3 dx dt equals to z. Now, since the 2 sides have to be in 4, then z must be equal to 5, and dz dt, as you can see, is equal to 1. Then I think we're almost done. Because when we simplify this one, we'll end up having these 3 cancels out. We have 4 of dx over dt, but we have 1 more, so 5 dx dt is equal to simply 5. And dx dt seems to be 1. Choice B. Alright, here we have limit of the function as x approaches 3 is equal to 7. Which of the following must be true? Then should it be continuous? We can see if it's continuous if and only if f of 3 is in fact equal to 7, but we don't have that, so we have no idea. Is it differentiable? It has to be continuous first. So, in fact, we have no idea about that. And f of 3, does it have to be 7? Once again, we have no idea. So none of them will be correct. Now, which one of them has the y equals 1 as an asymptote? Since y equals 1 is a horizontal line, we are looking for horizontal asymptote has to be equal to 1. In case of ln of x, it's ever increasing function, slowly but surely ever increasing function. So this one is not it. Sine of x is all oscillating function, therefore this is not it either. Now we have these three candidates. So when we look into, in this case, horizontal asymptote is equal to 0, so this one is not it. Horizontal asymptote is simply the limit as x approaches positive or negative infinity for the function f of x. Now, as x approaches infinity, we get to realize that this, in fact, is equal to 1, while this one is approaching infinity. Therefore, our answer will be choice C. Alright, f and g be the odd functions, and p and r, s are non-zero functions defined as below. Alright, so which must be odd? So here, odd function of the odd function, in fact, if you have to look at that, simply to check up on that, what we are looking for is this, is when you plug in negative x to the odd function, the result has to be negative of the original function. Now, in order for us to test upon that, we are simply looking at this. But since g is an odd function, what's going to be happening is this. This is equal to f of negative g of x. But since f is an odd function, we'll end up having f of g of x. So therefore, yes, the first one is an odd function. Second one, we end up getting f of negative x plus f of g of negative x. In fact, since both of them are an odd function, we end up getting negative f of x minus g of x. To fit the structure, we can factor out negative, then we end up having f of x plus g of x. And that was exactly the original function. So in fact, yes, second one is also an odd function. But the third one, here we have f of negative x times g of negative x. Then what's going to be happening, each one will bring out the negative and end up simply being f of x times g of x. This in fact becomes an even function, not an odd function. Therefore, our answer is number 1 and number 2 only, which is choice C. Alright, that's it. Have a nice day. Bye-bye.